pencil, calculator, reference table. It's all up on the chalkboard. All right, you have a lab worksheet that was presented to you. And on the top of the lab worksheet, I would like you to go ahead and put your name. This is class period 5, so please add that to the top of your worksheet. Everything else has to be off your desk. You need the desks to collect data in the lab. If you put things out on the desk, you're going to have a problem collecting data. You're going to have things in your way. Now let me explain to you what we're going to do. And I'm going to make a little sketch up here. You may want to do that as well. What we're going to do, you should see, or around the room, some of the desks have some pieces of tape which are labeled 1, 2, and 3. There are some of these around the room. And what we're going to be doing is using one of the buggies that we used in that lab a couple weeks ago. Remember that lab where we had the buggies out in the hallway? We're going to use them again. And we're going to have the buggy go from tape number 1 to tape number 2. That's what we're going to call a length. And then we're going to quickly turn it as it's on and have it continue on to the middle of tape number 3. That's what we're going to call the width. Okay. And as it does that, what we're going to be doing is timing it as it goes from 1 to 2 to 3 and recording those times here in this table. But before we begin, I'm going to break you up into groups. I'm going to give each group 2 meter sticks. And as a group, I'm going to ask you to measure the distance from the center of tape 1 to the center of tape 2. And you're going to measure it to the nearest 100th of a centimeter. See, it says right here, nearest 100th of a centimeter. You're going to record that length in the length column. And then you're going to do the same thing from the middle of tape 2 to the middle of tape 3 with those 2 and record it as the width. You follow what I'm asking you to do? Let's just do that. Okay. And then once everybody has that, we'll walk through with the buggies and timing and so forth. So let me break you guys up into groups. You'll have to get up and out of your chairs to do this because there's tape on particular desks in the classroom. So if I remember correctly, there's some here, 1, 2, and 3. And I'm going to have the 2 of you join these gentlemen over here. So your 2 meters to use to make those measurements. Let's see. There's a 1. There's a 1, a 2, and a 3. I'm going to have the 4 of you work together and getting those lengths of this. So you can get out of your chairs and go ahead and do that. I'm going to have the 2 of you come on over here and join Chang and Noah. You're going to put your binder off the desk. Take 1, take 2, and take 3. Here's your 2 meter sticks.
Don't measure from here to the edge. You measure from
all right. So come on over here. Take 2 and take 3. All right. So I'm going to have the 3 of you work.
It's a meter stick.
Let's see. This is tape 1, tape 2, and I'll get a tape 3. Right. But you can start with your legs. You can take 1 and 2, 3, and the 3 of you will work together. Tape 1. This is 2. And I guess I'll get that other piece. Why don't you come out around the side?
Was that 52? No, yeah. Yeah. So the width is 6, 7, 62.8. Oh, nearest 100. 0.8. Just put 0. Nearest 100. It's 2.80.
It's put 3 on this. Yeah, right there. Thank you.
58.
Middle.
It's not long enough. Yeah, that's way better. So what is this? It's 100.
So remember, 1 stick is 100 centimeters. 1 stick is 100 centimeters. And I'm just going to make up some numbers. Once you have the length and the width, I'll take those meter sticks back. And let's say 42.51. Thank you. Once you have both of those measurements recorded to the correct precision, you can bring those meter sticks back up to me. You should have the same precision as I have here out to the 100th of a centimeter, right? We're told to do it to the 100th of a centimeter. Once you have those, you can bring the meter sticks back up to me, and we'll move on to the next stage of the lab. Thank you. Thank you. Thank you. Okay. Now, one person in the group, I'd like you to pull out your Chromebook and open up to a stopwatch. One person in the group needs a stopwatch. You can do that on your Chromebook. One person in the group needs the Chromebook, only one. And here's what you're going to do. And I'd like not to scream, so I'm not talking over you. If you could listen, please. What you're going to be doing now is recording the 3 times as the buggy goes from tape 1 to tape 2 to tape 3. So this is what you're going to do. If you have one of these buggies, you have a double-sided switch. You're going to push it, turn it, push the switch in the direction you want the car to go. So I would do something like this. Ready? Go! You're not going to do it. Stop. That would be one try. Then they reset the stopwatch. You do it again. Did you see what I just did? You got to get 3 of those as a group, okay? I'll give you a buggy to use to get those 3 as quickly as you can as a group. So you need to go over and help your teammates. Get up out of your chairs, come over and help your teammates.
Tell me when. Yeah. And you gotta turn it.
Here, so.
That started behind or right on?
You start it before you put it down, just like I did over there. If you're paying attention, you understood what to do.
You start here.
You start it at the table. Once you have your 3 times, bring the buggy on up to me. Once you have your 3 times, please bring the buggy back on up to me. Thank you. Shouldn't take too long to get those 3 times. And then you can have a seat. Okay, so there's still 3 buggies out there. I need them back when you're all done. Then you can put the Chromebook away. You don't need calculators for this. You are measuring 3 times, getting them in the data table. Then you are returning the buggy and putting the Chromebook away, taking your seat. That's it. You were not instructed to do anything besides getting the 3 times. Get 3 times, return the buggy, have a seat. Put away your Chromebooks. They are not needed for the rest of today. All right, I'm still missing a buggy. Who has a buggy? All right, now everybody should be seated, looking up at the screen so you can follow along and get 10 out of 10 on this lab. Okay, so you've got 3 times. Your next job, and you're going to do this individually, is calculate what the average is. And I'm asking you all to do that individually because if your partner messes up and you're relying on them, you just lost a point on the lab because of their mistake. You should be doing it yourself. How are you calculating that average? Add them up on your calculator. Get a sum. You're doing it for yours, not mine. I just made up numbers. There's my sum. Now to get the average, you're going to divide that by 3. And you need your average. Averages always carry the same precision as the data you collected. So since all your times went to the 100th place, this average needs to be rounded to the 100th place. Mine just happens to automatically get there by coincidence, but please record that out to the 100th place. Once you have it, check with your partners and make sure you agree on what that average is. And then we'll go on to question 1. We'll work it out together so we review how to do these before your test. And then C-Chang, can you put your Chromebook away, please? Okay, does everybody have an average? We got 1 more. Well, you want to make sure you know how to do an average. Average of 3 measurements. Make sure you're doing it correctly. Add them up, get a sum, and then take that sum and divide it by 3. Don't just put this plus this plus this divided by 3. That won't work. You'll get the wrong answer if you do that. Okay, ready? Okay, let's now go to question 1, and we're going to change this. Please change the question so it says calculate the displacement that the constant velocity car traveled. And we're going to do this to the nearest 100th of a centimeter. We're then going to convert it to meters. So if I were to go back to this picture for a minute, remember that the car went from 1 to 2 to 3. Where is the displacement in that picture? That's right. The displacement is that arrow right there between 1 and 3. Now, how are you going to find that? That's right. That will give you the magnitude of the displacement. So we're all going to always start a calculation that you're showing work for with the equation. Now, in this picture, the length is side A and the width is side B. So the displacement is side C. So the numbers and units you're going to plug in come from the first data table, including the units. Don't drop the units or you will lose a point on your test next period. You'll also lose a point on the lab today. So I'm going to plug in my numbers. You have to plug in yours. Make sure you surround those measurements with parentheses because you are not adding areas together. And then you're going to get the magnitude of your displacement to the 100th of a centimeter. And the reason it's to the 100th place is because we have an addition sign in there. We keep the precision when we add numbers together. We don't drop digits. So there is my answer to the 100th of a centimeter, or at least half of the answer that's required. Yes. Yeah, well, yes, I am. Addition requires you to keep the precision of the measurements. These both go to the 100th place, so my answer is going to the 100th place. I even told you to do that here. In the directions of the question, I told you to do that. But that is what you're going to do on your test next period. When you have a question like this, you do it to the same precision as the numbers you were given. If you drop digits just willy-nilly, being sloppy, you're not doing it correctly and you're going to lose credit. Now, next thing it says is to convert that to meters. So when we convert it to meters, now you got to look up that prefix centi on your reference table. What is the prefix centi? Take a look. Look at your reference table, page 1. What's the power of 10 associated with centi? 10 to the negative 2. So you're going to do this with your numbers, not mine. I'm just showing you how to lay it out so it looks correct. You have to do it with your numbers. And then you can check with your partners to make sure you're getting the same answers. And you keep all of the digits. Okay, so that is half of the answer that I need, which is the magnitude of the displacement. But remember that displacement is a vector measurement, which means that this answer needs something else, right? What else does it need? A direction. When I come up to this picture, the way we're going to find the direction is by finding this angle here inside the triangle with the horizontal. All right, I want you to find that angle theta in your triangle. Do you remember how to come up with the angle in the triangle? What trig function you're supposed to be using? Josiah, what are we supposed to use? Which is which trig function? Which one is that? Sine, cosine, or tangent? So, you can also look at your reference table. It's on the geometry page. Tangent. So we're not going to use tangent. We're going to do the inverse tangent. So to get the angle, you're going to do the inverse tangent of the opposite side length over the adjacent side length. Now on our picture, which is the opposite side? The length or the width? The width. So we're going to say this could also be written as theta equals the inverse tan of the width over the length. Now you can do your substitution with units. I'm using my numbers. You use yours from the first data table. And then you're going to solve it to get an answer for the direction. We should all know how to type this into our calculators. Good practice for next period's test. And all of our answers always go to the nearest degree. So you're going to round it to the nearest degree. And those two boxed answers are my final answers to this question. You have to do it with your numbers, not mine. Make sure you're plugging in your values, not mine. And then once you have them, check with your partners to make sure you're getting the same displacement in centimeters and the same angle in degrees, because you should be. Yeah.
So how did you know which angle?
This one I'm telling you, I want it here. Remember when we do it on a test and you have your north, south, east, west, let's say it was here, you would measure all the way around there. It's always from the positive X direction. So here's our positive x, okay? So I'll give you a minute to finish working that out. Check with your partners. Make sure you all agree on those measurements, those calculations. And then we'll go on to question 2.
Can I show you? So my question is like, since we divided, I got this number, but is that the?
You have to round it to the nearest ones place, so it's to the nearest degree.
So that's just what I do, and then I don't worry about it. Like I just do it.
Angles are always to the nearest degree. That's right. But you're going to lose points because you're missing units everywhere.
Yeah, no.
Okay, you got to go back and fix that.
If you go into side, instead of like, it will give you the answer. It will in scientific notation. If you do in normal, it will give you it like that. Instead of 23.3, you put it inside like 2.3.
Now I'm trying to.
Yeah. Oh, I don't know this word. Yeah, I mean, you could put it inside. Then
Yeah, there's no reason to have this in scientific notation today, though. We don't need scientific notation for any of this, right, on the lab. Okay, are we all set with question 1? Can we go on to question 2? Okay. Question 2 is asking you to find now the distance that the car traveled. Distance. What type of measurement is distance? Scalar or vector? Scalar. How are we going to calculate the distance that the car traveled from this picture? What are you going to do? Add the length and the width. So let's write that as an equation. To do this today, to get our distance, we're just going to add the length and the width together. So go ahead, plug in your values from table 1. Don't forget to follow every number you write down with the appropriate units. And then get an answer. Remember, since we're doing addition, we're going to keep the decimal places, which these go to the hundredths place. Then again, it wants you to convert it to meters. So you're going to set it up the same way we did previously. Centi is equivalent to 10 to the negative 2 power. And you're going to get an answer that keeps the precision. But now in meters, just moving the decimal essentially to where it needs to go. Once you've done that, you can check with your partners to make sure that you're getting the same answers that they are. Okay, we good? 3 and 4, we're going to use our guess method for. This way we can review how that's done for your test next period. Number 3 is asking you now to find the average speed of the car. What do you need to know? What do you need to know in order to calculate an average speed? Your reference table should help you with this, right? It's all on your reference table. What do you need to know, Bryce? The distance and the time. Now, where are we going to get the distance from? Yeah, your answer to question 2 in meters would be your distance. And where are we going to get the time? Nathan, can you tell me where am I going to get my time? Yeah, it's the average from the table on your front. Whatever you got as your group's average, that's what you're going to use as your time. Now, speed, remember, is V without the arrow. That's our unknown. What is the equation that we should be writing to help us calculate the speed? And we just copy this off the reference table. What's that equation? Logan, can you tell me? How do we find speed if I know distance and time? Excellent. Now we do our substitution with the units. You're plugging in your numbers, not mine. I'm just showing you how to set it up. And then you're going to solve it, getting an answer with correct units and sig figs. So what you get as your answer and sig figs will depend on the data that you had. I need 3 significant figures because my numerator had 1, 2, 3, 4, 5 sig figs, and my denominator, Pacific rule, 1, 2, 3, had 3. So my answer has 3 using the Pacific rule. Yours might have 4 if your time was 10 seconds or greater, because then you have another digit there. Go ahead, work it out, round it to the proper number of sig figs, make sure you have units everywhere, and then check with your partners to make sure that you all agree on what the answer is. Bryce, just put your Chromebook away, please. We don't need that for anything today. Okay, well, you're not going to be able to do that next period. Okay. We good?
I don't know if it's supposed to be on centimeters or centimeters.
Well, your final answer, I told you to convert it to meters, so we're doing it in meters. Okay. If I don't ask you to do any conversions, you just do it with the units that you're given. You don't have to convert it. All right, can we go on? All right, number 4. Now I want you to find the average velocity. Now I want you to find the average velocity. What do you need as givens to help you calculate an average velocity, Miranda? I'm sorry? The displacement and the time. Where are we going to find the car's displacement? Yeah, in which question? Number 1, right? Number 1. So our displacement's actually both of these things. Both of these things are your displacement. I'll show you how you can write that. You're going to take the magnitude first, 1.4178 meters for me, comma, and then the direction, which is your angle. The time, is it any different than what we had in the last question? No, it's exactly the same. So you're going to use the same time value. Now, velocity, is that scalar or vector? The vector. So this is V with the arrow. And what equation are we going to use to solve for this? Nikki, can you tell me what equation are we going to use to get velocity? Very good. The velocity is the displacement over the time. So when we do our substitution with units, we say that the velocity is the magnitude of the displacement, comma, the direction, divided by the time that you got. Make sure you're putting units after all your numbers so you don't lose some points on the lab. This will also be required when you take your test next period. Now, when you do this on your calculator, folks, you're only dividing the magnitude by the time. The angle doesn't change. So you're going to divide it out, getting an answer with proper sig figs. Then add the units, which here would be meters per second, comma, and since velocity is a vector, it needs a direction. And if you recall, the direction of your velocity is always the same as the direction of your displacement. So it remains the same angle, and then you can box it in as your final answer to that question. I'll give you a moment to work that out, and then check with the people you worked with to collect your data to make sure you're agreeing on what those measurements, that calculation works out to be.
$32 period.
11:09.
We don't get a brief.
Okay. Does any group need more time to work that out? We all set? Yes, we're set? Okay. The last question we're going to answer is number 5. You can see 6 has been crossed out. Now, number 5 is asking you, based upon the definition, what's the difference between average speed and average velocity? Now, I'm going to tell you there's 2 things, and I'm going to try to give you a hint. So you're going to tell me 2 things that are different about these when you compare them. The first difference, remember, average speed was calculated in 3, and average velocity was calculated in number 4. The first difference comes by looking at your givens. You see a difference in the calculation? They have different givens. That's your first difference. You got to tell me what's different about them. The second has to do with the types of answers you get. There's something else different in the types of answers you get. Now, I'm not telling you what those are. You can discuss it as a group, but you need to come up with the 2 things that are different about an average speed calculation and an average velocity. One of them comes from the givens. I'm giving you a hint. And the other comes from the type of answer you get. All right. So talk as a group, figure out what they are, and then go ahead and address that here. And then that lab is done.
No, this is the magnitude.